Now, we'll be looking at some example questions, and we'll be looking at questions that relate to forces between two parallel wires. The basic formula, of course, is F over L equals K I1 I2 over D. So we'll be basically looking at questions which want us to use that formula. And we'll be looking at a range of difficulties, starting with easier ones and then moving on towards harder ones. So let's start here with this first question. In this first question, you can see you've got a situation where we've got Y1 and Y2, and they are parallel to each other. Y1 is carrying 24 amps in this upward direction. It's 8 centimeters away from Y2, perpendicular distance away. And it experiences a 7.2 times 10 to the negative 4 Newton per meter force of attraction towards Y2. So there's some sort of attractive force here. And we need to, for this to happen, of course, there needs to be current flowing in Y2. And you're asked to basically to find the magnitude and direction. Let's deal with direction first, right? You might recall that for there to be attraction, what basically happens is that if the wires carry current in the same direction, then it's attraction. We have attraction. So there's the answer. Our current for Y2 is also going up. We know it's attraction, therefore same direction, therefore going up. That simple. Now, for us to get the magnitude, we would need to rely on the formula. So we'll just copy the formula down here. F over L equals K I1 I2 over D. Now note K is a constant, which is equal to 2.0 times 10 to the negative 7. Or you can, if you prefer, you can use the mu naught over 2 pi. They're the two things as well, because if you look up mu naught will be 4 times pi times 10 to the negative 7. So when you divide by 2 pi, it's the same thing. Okay. Now, we know that the force per unit length is 7.2 times 10 to the negative 4. So that here is your 7.2 times 10 to the negative 4. This K is 2.0 times 10 to the negative 7. I1 is 24. I2 is unknown. And your D is 8 centimeters, which of course you need to convert into meters. And that's why that's 0.08. So rearrange a bit. Oh, don't forget your power, of course. So it's 7.2 times 10 to the negative 4. And here's where your calculator can step in. And that gives us an answer of 12. So there's your answer. The answer is, for this to occur, there must be 12 amps flowing in the upward direction. Let's take a look at another quite simple question and just getting into the hang of it. So it's a very similar question over here. This time, we still have two wires. We're given two currents in opposite directions. You know the actual lengths, and you know the distance between them is 6 centimeters. And you're asked to calculate the force experienced by each wire and identify the direction of the force. As usual, let's deal with direction first. In this case, we've got one wire going up with the current going up, one wire with the current going down. The currents are flowing in different directions. Now, if the current is in different directions, then what that then means is that, well, the force will be repulsion. So you're going to have a force. This one's going to get a force to the left, and this one's going to get a force to the right. So that's quite simple. Force 1 on Y1 will be to the left. Force 2 on Y2 will be to the right. Just because they travel in opposite directions, that's enough for us to know that. Now we need to work out the actual force, the magnitude. Well, again, formula to the rescue. F over L equals K I1 I2 over D. We know K is 2.0 times 10 to the negative 7. Now, L is given here. Just make sure you don't get L and D mixed up. L is the length of the wire, which in this case is 35 meters. And D is the distance between the wires, which is 6 centimeters, which you should always change to meters. So those are very common mistakes, getting L and D mixed up or not changing it to the appropriate unit of meters. Make sure you always do that. And of course, I1 and I2 are both 25. So with that in mind, you can just really work out F. F equals K I1 I2 times L over D. And then you just multiply it out. And see what you get. And you'll get an answer of 7.29 times 10 to the negative 2 newtons. So what that would then tell us is, I mean, if you just think about this, whether we're doing force 1 or force 2, I1 and I2, you're just swapping them around. L and D are the same, K is the same. So then they're going to both be the same answer. So this is going to be 7.29 times 10 to the negative 2 newtons to the left. And this is the same thing, 7.29 times 10 to the negative 2 newtons to the right. And that's how you would do this question. We now make the question slightly more complicated than before. We still have wires. We still have wires carrying current. We still have wires exerting forces on each other, but this time we have 3 wires, Y1, Y2, Y3, and they are carrying different amounts of currents, which are all labeled for you, and their distances between each other are also labeled for you as well. Now you can get questions which ask you to calculate the force on Y1 and Y2 and Y3. You can do that as an exercise, but for the question we're going to look at, we're going to only focus on the force on Y2. It's going to focus on Y2, but you can, as an exercise, do it for Y1 and Y3 as well. Now in this question, you're told all wires are 50 meters in length, so not shown in the diagram, but they're 50 meters in length. Just quickly draw that in there. All right, so calculate the net force on Y2. Well, think about what happens from Y2's perspective, right? We've said many times before, if you've got 2 wires, they'll experience, and they're carrying current, they'll exert forces on each other. So Y1 is carrying current going up, Y2 is carrying current going up, so there should be some force of attraction from Y1. So that, for Y2, will pull it to the left. Now, on the other hand, if you take a look at Y2 and Y3, they're also both going up in this case, which also means Y2 should also experience a force of attraction to the right. And you have that. You've got force of attraction there to the right as well. So these 2 forces of attraction from Y2 perspective is actually pulling Y2 in 2 opposite directions. So the net force that you need to work out, as per the question, is really going to depend on which force is bigger and which force is smaller, and then it's the net sum, right, of these. So let's firstly work out the actual force, right? So to do this, we of course use the formula F over L equals K I1 I2 over D, which means F, which is what we're interested in, is K I1 I2 over D times L. Now for force 1, we have 2 times 10 to the negative 7 being K. Your I1 in that case is going to be, well, from Y1, which is 20, Your second one will be y2, which is 30. The length of the y is 50 meters, so that's 50. Now the distance here is 3 centimeters, so that will be 0.03. And that would leave you, after calculation, with an answer of 0.2 newtons. Okay. Now, we could do the same step with force 2. Force 2 again would be K, so it's 2 times 10 to the power of -7, times I1, which is, in this case, going to be, let's go with 40, times I2, which is 30, because it's between these two, times, well, 50 meters in there. Now, you're then going to divide that by 0.03, no, 0.05 in this case, sorry. So, quick calculation, 2 times 10 to the -7 times 40 times 30, divide by 0.05, that's going to give you 2.4 times 10 to the -1, or in other words, 0.24. So in other words, this is 0.24 newtons to the right. This is 0.2 newtons to the left. So your net force is just going to be, well, if we think of to the right as positive, 0.24 minus 0.2, which is 0.04 newtons to the right. And that would be your answer there. Okay, it's 0.04 newtons to the right. Now there is a net force on that wire, and we know that net forces will result in acceleration through Newton's second law. So now that they ask us to calculate the acceleration if it's not fixed, well, you know it's 10 grams. So this question is quite simple. You just recognize, well, you've got the force equals 0.04 newtons to the right. And you know F equals ma, where m is 10 grams, which is 0.01 kilograms. So that means 0.04 equals 0.01 times a. So a must equal 0.04 over 0.01, which is going to be 4 meters per second per second. Now, if our numbers were correct, that would give you the right answer. I'm not so sure that a 50 meter wire, I'm not so sure that a 50 meter wire would realistically be 10 grams. Having said that, if we ignore the fact that it's a 50 meter wire is very unlikely to be 10 grams, that would basically give you the acceleration that it would experience. That's how you do that question. We'll look at one more question involving wires and attractive forces. So this one's now a little bit more involved, but is still basically following the same idea. Now, in this question, you've got a current of 2 amps flowing along this rectangular loop. This rectangular loop has dimensions of 5 centimeters times 20 centimeters, so it's a rectangle. And this long side, 20 centimeters, is close to this wire, which has 5 amps flowing through it, and it's 4 centimeters away. You are asked to calculate the net force exerted on the loop by the wire. So as you look at this question, you need to consider, why is there a net force in the first place? And the reason why there might be a force is because if there is a current flowing here, then that means, because the loop is, well, rectangular, the current would also flow down there, the current would also flow left here, and the current would also flow up there. So you can't only pay attention to the fact that there will be current flowing there, but you need to also consider the fact that the currents will flow down here, to the left here, and up here, and basically clockwise around this loop. Now, when you've got wires that have currents flowing through them exert forces on each other, but you need to remember that the wires exert forces on each other because they are parallel. Now, you have a parallel wire here. Those two are parallel. But what is not parallel are these ones here. And you also have another actually parallel wire over here. So we can ignore the vertical segments because they're not parallel, so no forces will be exerted on them. However, as you're going to get current flowing like this, you can basically think of this as the 3-wire question, very similar to what we worked on before, except this time, when we're trying to work out the net force on the loop, you need to think of both this second wire here in the middle, we'll call that wire 2. We need to think of this wire down here, which is wire 3. All of them have forces exerted on them by wire 1. And the answer to the net force on the loop is equal to the force on wire 2 plus the force on wire 3, inclusive of direction, of course. Okay. So really, we just need to use the formula F equals K I1 I2 over D times L. We need to use that for Y1 and Y2 to work out the force on Y2. We need to work out the force on Y1 and Y3 to work out the force on Y3. Consider the directions, and then add them up. So let's do Y2 first. Y2, we've done this before. It's K, which is 2 times 10 to the negative 7. I1 is 5. I2 is 2. L is the length of the wire, which is 20 centimeters. But that is going to be 0.2 meters. You have to convert it into meters, remember? Now you need to divide by the distance between Y2 and Y1. Well, that's just this distance here, which is 4 centimeters. And of course, you again need to convert that into your SI units. So that's 0.04. And so that gives you, after typing into the calculator, an answer of 1 times 10 to the negative 5 newtons. We've got the force on Y2 in terms of magnitude. You also need to think about the direction. It is going to the right. This is going to the right. So it's attraction, which in this case means up. It's being attracted to this wire, so it's going up. Now I'll do the same thing with Y3. Now F must equal 2 times 10 to the negative 7. I1 is 5. I2 is the current flowing through Y3, but given it's a loop, the current will be the same everywhere. Think Kirchhoff's law of current, right? Kirchhoff's current law. So it'll still be 2. Now the length of Y3 is also the same as the Y2. So that's also 0.2. But what is different though, is that it's further away from this wire than Y2 was. And you're going to have to look at the distance. Well, if the 4 centimeters takes you to Y2, and there's a distance of 5 centimeters between Y2 and Y3, that means it's 4 plus 5, which is, well, 9 centimeters. Right? This will be 9 centimeters, which of course is going to be 0.09. And so then, okay, everything is the same except the distance. That gives you now an answer of 4.44 times 10 to the negative 6 newtons. You need to pay attention to the direction. Well, so Y is going to the right, y3 is going to the left. These are opposite directions, which means it is repulsion. And if it's repulsion, that means downward. Once you worked out both, then the net force, if I take positive to be up and negative to be bottom, would be 1 times 10 to the negative 5 minus 4.44 times 10 to the negative 6. And that will give me an answer of 5.56 times 10 to the negative 6 newtons. Because it's positive, that means the answer will be upward. And that would be how you would do this question. Remember, just use the formula. F equals K, F over L equals K, I1, I2 over D, where K is 2 times 10 to the negative 7. And basically, you should be able to apply that to situations like this, and then you'll be able to get answers to your questions. That's basically how you do it.